Windows Time Service. While administrators are busy performing backups, fixing client configuration issues and freeing up disk space, and doing the myriad of daily tasks that makes our lives worthwhile, many forget to give consideration to the time on their servers. Okay, you at the back, I can hear you already. The time service? Well, is it important anyway? Well, yes, actually it is. Now, as you'd probably be aware, computers keep time on their internal clocks, which not only tells us when it's time to go home, somewhere around the very late evening for most of us, but it also allows you to perform functions that require the date or time. Now, let's face it, if the time is out on your server, backups don't start when they should. Auditing doesn't tell you exactly when someone did something. And of course, if you have shift workers that need to clock on and off, well, not keeping the correct time can cause all sorts of problems. The Windows Time Service automatically synchronizes the local computer's time with other computers on the network using Coordinated Universal Time, or UTC. But the time source for this synchronization can vary, depending on whether the computer is joined to an Active Directory domain or a workgroup. When the computers are part of a workgroup, a local administrator on each PC must manually configure the time synchronization settings. However, in a workgroup, a single computer can be identified as a locally reliable time source by configuring the Windows Time Service on this computer to use a known accurate time source, such as a server available on the internet. Then all other workgroup computers can be manually configured to synchronize their time with this local source. Now, when a client computer belongs to a Windows Active Directory domain, the Windows Time Service on the local computer configures itself automatically, using a Windows Time Server that is available on a domain controller. The Windows Time Service configures a domain controller within its domain as a reliable time source and then synchronizes itself periodically with this source. Now, these settings can be modified or overwritten depending on your specific needs. The default Windows Time Server is the domain controller that holds the PDC operations master role. So it's extremely important that you ensure that this domain controller's time is accurate, or it will cause the other computers in your network that rely on this server to have inaccurate time. Now, whilst I'm on the subject of Windows Time and Service and accuracy, it's important to realize the Windows Time Service uses the Simple Network Time Protocol, or SNTP. Now, don't confuse this with the Network Time Protocol, or NTP. Although SNTP is a derivative of NTP, NTP is much more accurate, keeping time within 1 microsecond. In contrast, SNTP uses what is referred to as loose synchronization, which keeps the synchronized time of computers in an enterprise within 2 seconds of each other and computers in a site within 20 seconds of each other. Now, in a workgroup environment, it's easy to set up a computer to query an external internet-based time server to keep up to date. Now, at our command prompt, we could simply use the nettime command followed by the /set SNTP switch, and then followed by an IP address or a DNS name. But in a domain environment, doing this is not recommended, and there's 2 reasons why. Firstly, in a domain-based environment, the client's Windows Time Service uses Kerberos authentication to securely contact the local time server, which we already know is the PDC emulator by default. When using Kerberos authentication, the client is more secure, as part of the ticket it generates to request information from the time server is encrypted. The time server then decrypts the packet, modifies the contents of the packet, and resends it back to the client, re-encrypting it with the client's private key. Now, the second reason that we don't want to use the nettime command, this one here, in a domain environment, is if that the client synchronizes with an external server which is outside the local time of the domain controller, this can cause the local computer to fail to synchronize with a domain controller, and this can lead to Kerberos authentication to fail. This can also mean that certain key services that require network authentication, such as file and print, will also fail. Now, that's why we recommend that only one server in your root domain pulls the time from an external source, and then all of your other systems can remain synchronized with each other, preventing these problems from occurring. Okay, so we know that we need our PDC emulator to keep good time, but how can we configure it? Well, as contradictory as this sounds, we will use the nettime command I mentioned a moment ago. Now, I know I said not to use it, but in the case of the time server, it needs to get its time from a reliable external source. So at a command prompt on our time server, we'll type in nettime/set SNTP, followed by the IP address or the DNS name of the external server, and then we hit enter. Now, to use a server on the internet, the PDC emulator must be allowed to contact the external time server using SNTP on UDP port 123. So make sure that you do allow this traffic through your firewall, or you will run into some problems. Now, there is a default time server that your PDC emulator and your client machines, in the case of a workgroup, will use as an external time source. Now, you can change this to a different one if you wish by using this nettime command, but the default time server is listed in the Windows registry. So to look at this, we'll click on Start, and we'll click Run, and we'll type in regedit, and now we'll navigate to the HKey local machine, System, Current Control Set, Services, and we'll scroll all the way down here until we find W32 time. Now I'll just expand this just to make it a little bit easier to read. If we expand this one out and select the parameters, we can see here the NTP server defaults to time.windows.com. Now this is the default external time server. Now you can double click here and change this if you wish, or you could use the nettime command we spoke about, but for safety's sake I recommend you using the nettime command, as editing the registry directly is always the last resort. Now, the other issue you might have, especially in a larger environment, is the need for more than one time server. Now, when a computer first boots up, it uses the net logon service to contact a domain controller to synchronize its time with. Now, you can imagine the problems you might have if you had 10,000 client computers all wanting to synchronize their time with the PDC emulator all at the same time. Now, in this example, it's more than likely, if you've got 10,000 client computers, that you have multiple domain controllers in your organization servicing the client logons. So why can't we use these servers to synchronize our time? Well, we can, and the best news is that it's practically automatic. And I'll say practically because the PDC emulator can, and probably will at some stage, be moved from its original location, in which case we'd have to edit the registry on the new PDC emulator and modify the registry to accept the new time server. So what we'd do here, again on our parameters tab, is we'd right click and select new, and then we'd select new D word value. Now in here we'd give this a name, and we'd call this reliable time source. And at this point we'd give it a value of 1. Now this indicates that the server is a reliable time source. If this server is no longer required to be identified as a reliable time source, then we'd simply change the value back to 0. Now in the case of having additional domain controllers in your organization, each domain controller will obtain their time from the server that holds the PDC emulator role, unless another server is designated as being a reliable time source, and then the other domain controllers will attempt to synchronize with that instead. But as far as Active Directory domain clients go, they will attempt to synchronize with their authenticating domain controller when they log on. So how do we find this mythical PDC emulator if we don't know which server it is? Well, we can open up a command prompt, which we've already got open, and we can use the W32TM command with the /monitor switch. We hit enter, and we can see that the PDC emulator in fact is our current server of 192.168.0.11 with the name server01.testdomain.com. Okay, so our server's sorted out, but let's take a look at Windows time from the client's perspective. So if we want to manually synchronize our local client computer with a local time server, we can open up a command prompt and simply type in W32TM/resync, and then when we hit enter, it will send the resync command to the local computer. However, if we want to resynchronize a computer that's different to the local computer, we can simply add the /computer switch followed by the name of the client. In our case, we'll synchronize XP client, and then we can hit enter, and it will send the resync command off to the XP client machine. So if we've got Joe down the hall who's complaining that his time's out of whack, we can simply issue a command like that, and we can fire it off and remotely reconfigure his time. Now there's another couple of switches here that I want to actually discuss. I'll just delete this here, and One of the other ones here is the rediscover switch. Now if your client's local time is more than 15 hours out, you're going to have problems resyncing with the time server. Now in this case you can issue this same command with the /rediscover switch to redetect the network configuration and rediscover network resources. Now this will cause the local client to resynchronize with the server. Now another thing is you may have a client that seems to be out of whack with the server as far as its time goes, and you want to monitor what the status of it is. In this instance here we could use the strip chart switch as well as the computer switch, in which case we'll use our XP client again, and we'll hit enter at this stage. And what we can actually see happening is every couple of seconds this particular server will actually go out and query that client and find out what the offset is compared with the server's time. Now this can help us troubleshoot this particular client to see if his PC is actually keeping accurate time. Now I'll actually just stop this capture here for a moment, and what we need to look at here is this offset, this +02 etc all the way down here. Now this offset is calculated by subtracting the time that our server sent the request to the client and then the time that the client sent the request back to our server. Then the local time that the server sent the reply back to the client is subtracted from the local time that the client received the reply. Now these two values are then added together and then divided by 2, and that's how they actually come up with this value. Now at this point I should probably also mention what happens when a client's clock is not in sync with the time server. Firstly, if the client's time is behind the server, so in other words, if the client has a time of say 1:22 p.m. and the server is at 1:23 p.m., then the client's time service will automatically change to be in line with the server. If the client's time is faster than that of the server and it's more than 3 minutes faster, then the client's time service will again change the time to be in line with the server. But if the client's time is faster than the server but it's under 3 minutes faster, then the client will slow down the clock to be a quarter of its normal speed. Once the clock is within 15 seconds faster than the server, it will speed up its clock to be half the server's normal clock speed until the times are in line, and then normal time will recommence. Okay, so this is all good, but we've covered a lot of ways to configure the time on our computers, but there's got to be a better way than this. Well, I'm glad you asked, because yes, there is, and it's our good old friend group policy. So we can use group policy to configure the Windows time service for our entire domain if we like. So what we'll do is we'll click on Start, Administrative Tools, we'll open up Active Directory, Users and Computers. Now I'm not actually going to go and deploy this group policy for our environment, so normally you wouldn't do it this way, but we're just demonstrating what we can do with group policy here. So I'll right click on my test domain and I'll select Properties. I'll go up here to the Group Policy tab and I'll create a new group policy object, and I'll simply call this one Time. So I'll select that and I'll select Edit, which brings up the Group Policy Object Editor. Now under the computer configuration we need to expand our administrative templates, System, and down here we can see the Windows Time Service. Now on the right hand side we have two options. We have the time providers and the global configuration settings. So I'll double click on global configuration settings, and you can see we've got three options as per any group policy object. We currently have it not configured, but we can enable it or disable it. I'm not actually going to enable this policy, but I'll select it for the moment because you can see down here that all these values have been pre-populated, and we've got quite a few options. Now I'm not going to go through all of them. What I recommend is, if you really do want to find out what all these things do, go to Microsoft's website and you will get a complete list of what each one does. Now in a nutshell though, these settings here are actually used to configure things like your polling intervals for your time servers and how verbose the logs in your event logs are going to be. So I'm going to click cancel on that one here, and I'll go over here to my time providers, and we have three options. We can enable the Windows NTP client, we can configure the Windows NTP client, and we can enable the NTP server. So if I double click on enable Windows NTP client, again we can see it's not configured. If I click enable, that's pretty much really all I can do here. Basically what this one does, this policy just simply allows a computer to synchronize with a time server. And that's pretty much it. So with that large explanation out of the way, I'll click on Next. And of course I'll click Enable so we can see what's going on with this particular policy. And this is to configure the Windows NTP client. Now down here you can see we've got quite a few options. So we'll go up to the top here and we'll just explain what these are. First of all, we can see our default NTP server, which defaults to time.windows.com, and we saw that a moment ago in the registry. Now next we have the type, and it's set to NT5DS. Now NT5DS means to locate and use a valid domain controller in which we would synchronize our time with. Now here we've got a couple of other options. We also have NTP, which is the same as saying use an external time server. We also have the no sync option, which is the recommended option for the PDC emulator or the server that's been manually configured to synchronize with an external time server. And finally, we have the all sync option, which lets the system decide on using any of the above. So that's kind of like an automatic setting. Next we have the cross-site sync flags, which defaults to 2. Now this is used to synchronization to occur with other servers outside the domain. Now the other options we can set here are 0, which is basically the same as saying none, don't synchronize with any servers outside our domain, or we can set it to 1, which is to synchronize with the PDC emulator only. Now by the way, this option here, the cross-site sync flags, it doesn't do anything if this type is not set to NT5DS. So if it's not set to NT5DS, you can set this to whatever you like, it's not going to do anything anyway. Now the next one we have here is the resolve peer back off minutes, which is currently set to 15. Now this specifies how long in minutes that the computer will wait before attempting to locate and contact a peer to synchronize with. Now that kind of works in line with resolve peer back off max times, which is currently set to 7. Now what this one does is it specifies the number of times, i.e. 7 times, that we are going to double the wait interval when repeated attempts to contact a peer to synchronize with fail. So in other words, what we're really saying here is if the wait interval is 15 minutes and we attempt to contact our peer and it fails, then we will double the interval wait. So in other words, we're going to contact them again 30 minutes later. But we're only going to continue to double that time, so the next one will be an hour and then 2 hours and so on and so forth, for a maximum of 7 times. Next we have the special poll interval, which is set to 3600 seconds. Now this is for peers that have been configured manually. This just specifies how often that we're going to wait before we poll them again. And finally we have the event log flags, which just controls the events that the time service sets. So we'll click on next, and then we'll click on enable the Windows NTP server. And this policy option simply says the computer that applies this policy will be able to service requests for time from this computer. Okay, so those are the group policy features that relate to the Windows Time Service. So let's move on and we'll discuss some troubleshooting. Now when troubleshooting the Windows Time Service, the event log is always a good place to start. There are a few key W32 time events that get logged to your system log. So when going through and looking for these events, the first thing I like to do is actually use the event log to filter out everything else, and it helps to make finding these events easier. Now the most common event you're likely to see in your event log is an informational event with an ID of 35. Now these events occur quite often, and they're logged each time a client attempts to resynchronize with the time server. In fact, if your time service is functioning properly, you should see these events occurring approximately every 8 hours, which is the default resynchronization interval for a healthy system. Now event IDs of 36 and 14s are warnings that your time service has been unable to synchronize with the time server, and the 14s indicate that your client was unable to locate a domain controller to synchronize with. In these cases, check that your domain controllers are up and that they're working properly. Now if you receive an event ID of 29, it indicates an error in which your client cannot contact a time server. When this occurs, your client will wait around 14 to 15 minutes before attempting to contact the time server again. Next we have an ID of 34. This is probably not such a common event. It appears when the time on your client is really out of line with the server, in fact more than 54,000 seconds out of line. Now you might not actually experience this particular error, but I've actually seen this event on notebooks that have been in hibernation for some periods of time and then resumed whilst plugged into the network, and therefore they haven't actually been rebooted to allow the time service to resynchronize. So the solution in this event can be to reboot the computer and it should resume normal time. Now on the PDC emulator you'll also see events with the ID of 37. These are perfectly normal and they actually indicate that the local time server is synchronizing with an external time server. So these events are purely informational. Now, one other thing I want to point out is events on the PDC emulator that have the event ID of 12. When the time service is running on the PDC emulator, it will send these events to the event log indicating that it has no time source. Now, when this occurs, you can set the PDC emulator to not synchronize at all by changing the value for the type entry in the registry to no sync. So if we go back to our registry and we're here at this key, the H key local machine system current control set services, W32 time/parameters. Now here under the type, we can see that our PDC emulator has the NT5DS type, and we have talked about that. This basically indicates that this server will use a domain hierarchy to synchronize. Now we can actually double click this if we like and enter the value of no sync, so it would enter no sync, and we won't see it anymore in the event log. Now, as I said, those particular ones are purely informational, so it really doesn't matter if we see them, but if you are getting annoyed by seeing them or you're concerned about what they are, you can simply enter this no sync in the parameters and that'll disappear. Now, of course, the default, as we saw, was the NT5DS. We also could use the NTP here, which would synchronize with a manually configured source, and of course, remember, we have the all sync option as well. Now, another point I'd like to make with regards to troubleshooting the Windows time service is when we actually looked at the W32 TM tool. But if you're going to use this W32 tool on a domain controller, it's necessary to stop the W32 time service. Now, running the W32 TM command and the W32 time service at the same time on a domain controller can generate an error because both are attempting to use the same UDP port. So when you finish using this W32 TM command, W32 time must be restarted. So to stop the W32 time service, we'd simply get to our command prompt here and we'll type in, I'll get rid of that first, and we'll type in net stop W32 time, and we'll hit enter, and we can see the Windows time service is stopping. Now we'll go back here and we'll say net start W32 time again, and we can see the service will now start back up again. Alternatively, if you like, of course, you can do this from the services MMC from your administrative tools. Okay, so in this video we discussed the importance of keeping the Windows time service accurate and the differences in configuring the Windows time service for workgroups and domains. We also took a look at the PDC emulator, which does hold the Windows time service role that other domain controllers in your domain will synchronize with. We also looked at how we can use the registry to designate other domain controllers as the reliable time server. We finally discussed client configuration, domain configuration using group policy, and troubleshooting what happens when the time service doesn't work properly. Now, if you do need to locate an external time server, just jump on your favorite search engine such as Google and perform a search for time synchronization, and you'll find a whole host of external time servers that you can use in your environment.